Hey, hello, welcome back. In this part, we are going to take a look at what's known as the stack. You will encounter this in every reverse engineering activity you will do, in every disassembling activity, in every program you will disassemble. You will encounter what's known as the stack. And in this part, it's what we are going to concentrate on. Okay. So generally speaking, a stack is a data structure that stores data values contiguously in memory. Unlike an array, however, you access, which means you read or write data only at the top of the stack. And to read from the stack is known as to pop, okay? And to write to the stack is said to push, okay? And the stack is also known as LIFO, LIFO-Q, okay? Which means last in, first out. And since values are popped from the stack in the reverse order that they are pushed onto it, okay? You can think of how you pile up plates on a table, okay? The last plate you have put on that pile is the one that you first remove, okay? When you start removing or you start moving, okay? Removing those plates from the pile, okay? So popped data disappears from the stack, okay? So all x86 architectures use a stack as a temporary storage area in RAM that allows the processor to quickly store and retrieve data in memory. The current top of the stack is pointed to by the ESP register, and the stack grows downwards from high to low memory addresses. So values recently are pushed onto the stack are located in memory addresses above the ESP pointer. Okay, so no register, especially no register, especially, well, how should I say this? No register specifically points to the bottom of the stack. Okay, although most operating systems monitor the stack bounds to detect both underflow, which means popping an empty stack, and overflow, which means pushing too much information on the stack conditions. Okay, so when a value is popped off the stack, the value remains sitting in memory until it's overwritten. Okay. However, you should never rely on the content of memory addresses below the ESP, because other functions may overwrite these values without your knowledge. Okay. So users of Windows ME 98, 95, 3.1 and earlier may fondly remember the infamous blue screen of death that was usually caused by a stack overflow exception. And this occurs when too much data is written to the stack and the stack grows beyond its limits. Okay, so modern operating system use beta bounds checking, okay, and error recovery to reduce the occurrence of stack overflows and to maintain system stability after one has occurred. Okay, so in the next part we shall take a look at what's known as push and pop. Okay, so right here in the diagram we are seeing the structure of the stack. Okay, so if we put something on the stack, it means we are pushing. Okay, and if we remove data from the stack, we are doing what's known as popping. Okay, so we are popping something off the stack. Okay, and the last we can only access the last element that is on top of the stack. Okay, we can only access that element. Okay, so the stack it doesn't look like this. Okay, it doesn't look like this is the structure of how you remove, okay, things of the stack, but the stack is usually upside down. Okay, it's usually upside down, so this image should be upside down, okay, in order to visualize what a stack is. Okay, but you can take this one to be the top of the stack and then you try to flip, okay, or move this image upside down. Okay, and that will be the structure of the stack. Okay, so in the next part we shall take a look at the push and the pop. So for those who don't know what assembly language is, you should check out my tutorial. The link to that playlist or to that exact video is in the description of this video. Just go inside the description of this video. You will find there the link to that playlist, and from there you can come back and watch this part, because we are going to be working a lot with assembly programs with assembly instructions. Okay, so you need to have some basics, some assembly basics, and some C basics. Okay, so for those who have never programmed in C or C++, you should check out my we have a YouTube channel. The link is there, and the link to that exact tutorial is right there in the description. Okay, so if you don't know what C is, if you are never programmed in C, check out that YouTube channel and check out that exact video. Okay, and after watching, you will come back and we do our reverse engineering activities or disassembling activities. Okay, so in the next part, we shall talk about the push and the pop. Okay, as we have seen them in this part. Okay.